Welcome to the deep dive. Today, we're locked into a really fascinating clash. NVIDIA and AMD, they're battling it out in the world of AI chips. And forget just gaming graphics for a second. This is about the core tech, the hardware that's driving this whole AI revolution.
Yeah.
It's hitting everything, right? Generative models,
Yeah.
huge data centers.
Absolutely. It's foundational.
Yeah.
And these two, NVIDIA and AMD, they've been rivals for ages in graphics.
Yeah.
But now that rivalry is really heated up because they're competing for AI supremacy.
Yeah.
I mean, this stuff is set to reshape pretty much everything.
Totally. So our mission here in this deep dive is to really pull out the most crucial bits from all the recent news and announcements. We want to give you a clear picture of where AI hardware is now and maybe where it's going.
Right. We've waded through the specs and the marketing buzz.
Trying to get you the key takeaways, maybe a few surprises without the overload. Sound good?
Let's do it.
Okay.
So let's dive right into the silicon itself, the heart of the competition. We really need to compare NVIDIA's current big gun, the H100, with AMD's main challenger, the MI300X.
Okay, so first up, NVIDIA H100. This chip is, well, it's built for the really heavy lifting, large-scale AI, high-performance computing.
Yeah.
The big headline claim is that huge speed up, potentially 30 times faster in AI training compared to the last generation.
Which is a massive leap.
It really is. And they've got this thing called the transformer engine built in. Now, for listeners maybe not super deep in the tech, transformer networks are kind of the architecture behind a lot of the really advanced AI we see.
Like ChatGPT and similar models.
Exactly. So this engine is specifically tuned for those kinds of complex calculations.
And you have to think about the data these things chew through. The H100, it boasts a memory bandwidth. Think of it like a data highway of 4.9 terabytes per second.
Wow.
Yeah, and it's paired with 80 gigabytes of this super fast HBM3 memory, high bandwidth memory.
So wider highway, faster data flow to the processors.
Precisely. And for the really, really huge AI models, NVIDIA uses tech like NVLink and NVSwitch. These basically let you cluster lots of H100s together so they act like one giant interconnected brain.
Okay, makes sense for those monster models. Now let's flip to AMD, their MI300X.
Right. This is their heavy hitter for AI. And the first thing that jumps out, it's the memory. A whopping 192 gigabytes of HBM3 memory.
Whoa, okay. That's more than double the H100,
Yeah,
right?
more than double, yeah.
Mm.
And that data highway, it's slightly wider too, clocking in at 5.2 terabytes per second.
Okay, so more memory, slightly more bandwidth. What else is different?
Well, a really interesting point is how AMD built it. They're using an advanced chiplet design with 3D stacking.
Chiplets, like
Yeah.
Lego bricks for chips.
Sort of, yeah. Instead of one giant chip, they connect smaller, specialized chiplets together. And the 3D stacking means they build upwards, not just outwards.
Ah, like a skyscraper instead of a single-story building.
Exactly. It lets them pack more power and memory into a smaller footprint. And that can help with performance and power efficiency.
Okay, interesting architecture. And how does it perform?
Well, early benchmarks we're seeing suggest it's very competitive, especially for something called LLM inference.
LLMs, large language models, like the ones powering chatbots.
Right. And inference is when you actually use the trained model, ask it a question, get an answer, generate text.
Got it. So, okay, let's try to pull out the aha moment here. It feels like NVIDIA with the H100 currently leads on the raw speed for training the models.
And they have that established software, which is crucial.
Right. We'll get to that. But AMD with the MI300X comes in with significantly more memory,
A lot more.
which could be really good for running those big models efficiently, that inference part, maybe handling larger models more easily.
That seems to be the trade-off emerging, yeah. Think of it like training is designing and baking a super complex cake. You need a really powerful, fast oven. Maybe that's NVIDIA right now.
Well-
Inference is like serving slices of that cake to tons of people simultaneously. You need lots of plates, lots of counter space. That larger memory from AMD could be a real advantage there.
That's a great analogy. And it perfectly sets up the next battlefield, doesn't it? The software.
Absolutely critical. The best hardware in the world is useless without the software to run it effectively.
So on NVIDIA's side, the big name is CUDA, Compute Unified Device Architecture.
Yep, it's their own platform, proprietary.
Yeah.
But, and this is key, it's deeply, deeply integrated with all the major AI tools people use. TensorFlow, PyTorch,
The standard frameworks.
the absolute standards. And what you can't discount is the ecosystem NVIDIA has built around CUA. We're talking over a decade of development.
Wow.
There's a massive community of developers who know it inside out. Countless libraries, tools, all optimized specifically for NVIDIA hardware running AI tasks. That's a huge head start.
Okay, that's a powerful advantage, that incumbency. So what's AMD's answer?
Their alternative is called ROCm Radeon Open Compute Platform.
ROCm.
And the first big difference, ROCm is open source.
Ah, interesting. So not locked into one company.
Exactly. And while, maybe it lagged behind CDA for a while, it's catching up. It's getting much better compatibility now with PyTorch and TensorFlow too.
So it can run the same kinds of jobs?
Increasingly, yes.
Yeah.
And here's something really important. ROCm is getting serious backing from some of the biggest cloud players, the hyperscalers. Think Microsoft Azure.
Okay, why is that significant?
Well, it signals that these huge companies, the ones building massive AI infrastructure, are actively looking for and investing in a viable alternative to NVIDIA's CUDA.
Right. They probably like the open source aspect, maybe gives them more flexibility, less vendor lock-in.
Precisely. Both for the open nature and potentially for negotiating power and choice in their setups.
Yeah, the takeaway on software seems to be Azure is the king right now, mature, massive community.
Definitely the standard.
But ROCm is improving fast, it's open, and it's getting support from major industry players, so the software gap might be closing.
It's definitely narrowing, particularly in research and for those big cloud providers.
Yeah.
We could see a more level playing field down the line.
Okay. And all of this, the hardware differences, the software competition, it all obviously impacts the market, right? The money.
Correctly. Yeah, let's look at the market dynamics.
When you look at AI GPUs currently, NVIDIA's lead is, well, it's stark.
Undeniable.
Their data center revenue for fiscal 2024 was over $47 billion.
Just staggering numbers.
And get this, that was a 200% jump year over year.
200%. That kind of growth just shows you the sheer demand and their current dominance.
And if you connect the dots, they have partnerships with basically everyone who's anyone in AI and cloud. OpenAI, Meta, Microsoft, AWS.
All the big buyers.
Yeah.
These deals really cement their position as the go-to for AI infrastructure right now.
Okay, so that's NVIDIA's picture. What about AMD?
Well, their data center revenue is smaller, around $6.5 billion for the same period. But crucially, it's also growing steadily.
Okay, so not insignificant and growing.
Right. And importantly, that new MI300 series, it is gaining traction. They're landing deals with big customers, Microsoft again, Oracle, Meta too.
So those hyperscalers aren't just supporting ROCm, they're actually buying AMD's AI chips.
They are, and AMD has publicly stated a goal they want to capture, something like 10% or more of the AI accelerator market by 2025.
10%. Still leaves NVIDIA with the lion's share, but
But it shows serious ambition, and winning those kinds of major customers proves they're a credible competitor, not just a niche player.
right. So the market takeaway, NVIDIA has a commanding lead, no question. The revenue proves it.
Yeah.
But AMD is clearly making significant progress. They're winning important deals, growing their revenue. It's not a done deal. The landscape is shifting.
Absolutely. It's becoming a real two-horse race in many ways, even if one horse has a big head start. And we should remember, these chips aren't just for those giant data centers.
That's a good point. We talk a lot about the cloud and massive AI, but where else do these things show up?
Well, gaming, obviously, that's their heritage. NVIDIA still leads with the RTX series.
Yeah, dominates high-end gaming.
But AMD's RDNA 3 graphics have been gaining market share, often seen as offering, good performance at potentially a lower price point.
So competition there, too.
Definitely.
Yeah.
Then back in the data center, like we discussed, NVIDIA strong in training, AMD targeting inference, and those memory-heavy jobs with the MI300X.
Right.
And then there's edge AI, embedded systems.
Stuff not in the cloud, but out in the world.
Exactly. Think robotics, smart cameras, advanced driver assistance systems in cars, industrial automation. NVIDIA has a strong position here with their Jetson modules.
I've heard of those, yeah. Little AI brains for devices.
Pretty much. But AMD is making inroads here too, especially in automotive and industrial applications, so the battle extends beyond the cloud.
Okay, so it's a broad competition. Which brings us to the future. What are they working on next?
Both have really ambitious roadmaps. NVIDIA, for instance, has been pushing their Grace Hopper superchip.
Grace Hopper.
Yeah, it integrates one of their CPUs and a powerful GPU onto a single package. Tighter integration, potentially better performance and efficiency for certain tasks.
Okay, blurring the lines between CPU and GPU.
A bit, yeah. And they've announced their next big architecture, codenamed Blackwell. That's expected to power their next-gen H200, maybe H300 chips.
So even more powerful hardware coming.
For sure. But NVIDIA is also investing beyond just the chips. They're talking about quantum simulation, more advanced AI agents, digital twins. It feels like they're building this whole integrated AI platform.
The bigger ecosystem vision.
Got it. What about AMD's future focus?
Well, a key thing for them is continuing to push that 3D stacked chiplet technology we mentioned.
Right, the skyscraper design.
Yeah, they see that as crucial for power efficiency as chips get hotter and more complex. They're also really doubling down, it seems, on optimizing for AI inference and tasks needing lots of memory.
Sticking to that strength. It looks like it. And critically, they'll be working closely with those cloud partners to keep improving and expanding the ROCm software ecosystem. That's essential for them.
So if we contrast the future strategies, it seems like NVIDIA is going broad, aiming for a comprehensive AI platform, hardware, software, the whole nine yards.
That seems to be the vision, yes. Very holistic.
Whereas AMD is maybe more strategically focused, targeting specific high-demand areas like inference and memory-bound tasks with efficient high-memory hardware while building up that open software alternative.
That appears to be the path, yeah. A slightly different angle of attack, leveraging their architectural strengths and the desire for an open alternative in the market.
Okay, so wrapping this up, where does this leave us? It's clear the race for AI chip dominance is incredibly intense.
And far from over. It's really dynamic right now.
Absolutely. NVIDIA, you have to say, has the lead currently. Performance in key areas like training, that mature CUDA software, the huge ecosystem, all those partnerships.
Significant advantages, no doubt.
Yeah. But AMD has really emerged as a very strong and credible competitor. They're offering something different, especially for inference, for those big memory needs, maybe for customers looking at total cost.
They're providing a real choice now, which is healthy for the market.
Definitely. And it feels like long-term success might not just be about having the absolute fastest chip on paper, right?
Probably not solely, no.
Yeah.
The strength of the software ecosystem.
Yeah.
How easy it is for developers to actually use the hardware. That's massive.
Yeah, and scalability, how well these solutions work when you deploy thousands of them. And those strategic partnerships with the cloud giants and AI companies.
Those relationships are absolutely key. Who integrates whose hardware deeply into their platforms will likely determine market share down the road.
So as we finish this deep dive, maybe a final thought for you, the listener, to chew on. We've seen these rapid advancements, these different strategies from NVIDIA and AMD. Thinking about the future, what specific applications or maybe technological shifts do you think will be the deciding factor? What will ultimately crown the long-term leader in AI silicon?
Yeah, will it be the next generation of massive language models?
Yeah.
Or maybe breakthroughs in scientific computing or robotics or something else entirely?
It's a fascinating space to watch, and honestly, the outcome of this competition between NVIDIA and AMD will shape so much of the future of AI.